This is a video walkthrough for practice 10C. In 1 through 6, we're asked to write the equation for each function and then find its domain and range. So I'm going to start in number 1 by identifying the parent function. We can recognize this shape as the shape of the square root function. The graph of the square root function looks like this. And so it is clear that this graph was moved left 5 and down 3 to produce the graph of the transformed function. So the graph of the new function has an equation of y equals the square root of x plus 5, because replacing x with x plus 5 moves the graph left 5, and minus 3 on the outside. And then the domain, if we look at the endpoint of the graph, the endpoint is at x equals -5. All other points are to the right, so x is greater than or equal to -5. And for the range, we can also look at that endpoint. That same endpoint has a y value of -3. All other y values are greater, so y is greater than or equal to -3 is the range of that transformed function. In number 2, we have a parent function that is the exponential function y equals 2 raised to the x power. And the parent function looks like this. And so it is clear that all the points on the transformed function are simply shifted down 3. We can shift a graph down 3 by subtracting 3 outside of the function. So 2 raised to the x minus 3 is equal to y. If we look at the graph of the transformed function, we can see arrows on both right and left ends and continuing with no breaks. So that means the domain is all real numbers. The range, however, is y is greater than -3. So we can see that the graph does not appear here below that horizontal asymptote, and the graph approaches a y value of -3 but doesn't actually reach it. In number 3, our parent function is y equals x squared. Y equals x squared has a shape like this, and the transformed function is simply a translation left 2 and up 1 to produce the new graph. So the transformed function has an equation y is equal to x plus 2 squared plus 1. The domain is all real numbers, since arrows on the left and right end of the graph indicate that the graph continues infinitely in both directions with no breaks. The range can be found by looking at that lowest point on the graph. So the lowest point has a y value of +1. All other y values are above that, so y is greater than or equal to -1 is the range. Number 4 has a parent function that is logarithmic, so y is equal to the log base 2 of x, and y equals the log base 2 of x looks like this. And we can see that this graph, the transformed graph that is a horizontal reflection, or a reflection over the y-axis of the parent function. So y is equal to the log base 2 of the opposite of x is the equation. Replacing x with the opposite of x gives us a reflection across the y-axis. The domain of the transformed function is x is less than 0. We can see that we only see graph on the left side of the y-axis, and the graph actually never reaches the y-axis, so it never reaches an x value of 0. The range, however, is all real numbers, since arrows on both ends of the graph indicate that the graph travels infinitely up and infinitely down with no breaks in between. In number 5, we see a cubic, or rather, looks cubic, but it's actually cube root because it is its y values are increasing at a small rate. To distinguish it from the cube function, the cube root function looks like this. That's our parent function, and it appears that this graph has simply moved down 4 and right 1 in order to produce the transformed function. So the transformed function has an equation y is equal to the cube root of x minus 1 minus 4 to move it right 1 and down 4. Arrows on the end, no endpoints, no breaks. So that indicates that our domain and range are both all real numbers. Graph continuing infinitely up and down, left and right with no breaks. In number 6, the parent is y is equal to the absolute value of x. Y is equal to the absolute value of x is that V shape with the vertex at the origin. And so what we can see here is that we have a reflection, we have a stretch, because this graph is twice as steep. If we look at the slopes, parent function has a slope of 1 on the right side, and this function has a slope of -2 on the right side. So that means that the outside of the function must have been multiplied by -2 in order to produce both a reflection and a stretch. And then the inside of the absolute value should be replaced with x plus 1 in order to move the graph left 1, and then plus 4 on the outside to move the graph up 4. Arrows on the end of the transformed graph, both left and right sides, indicate that the domain is all real numbers. The range is indicated by the fact that there is a top y value there. The y values go up to +4, but never go above. So our y values for this graph are less than or equal to 4. In 7 through 16, we're asked to find the domain of each function, and we're going to find it algebraically rather than graphically. The only problem operation, and remember your problem operations are division, even roots, and logarithms. So the only problem operation in this function is the square root. The expression that is under the square root, x plus 7, has to be either greater than 0 or equal to 0. So positive or 0. Subtracting 7 from both sides, the domain of this function is x is greater than or equal to -7. In g of x, the only problem operation we see is a division. And remember that the denominator or divisor of a division cannot equal 0. So x minus 5 cannot equal 0, and x cannot equal 5 is the domain. In number 9, there is no division in this equation. There is no even root. There is no logarithm. Therefore, there is no problem, and the domain is all real numbers. In number 10, I do see a problem operation that is a logarithm. The inside of a logarithm, 7 minus x, has to be a positive number, so it must be greater than 0. If I subtract 7 from both sides and divide by -1, changing the direction of the inequality, x is less than 7 is the domain of this function. In number 11, I don't see any division, I don't see any even roots, this is an odd root, and I don't see any logarithm. So an odd root is defined for all real numbers, therefore the domain of this function is all real numbers. In number 12, my problem operation here is division. Remember, it is the denominator of the division that can't equal 0. There's nothing to solve here since x is already isolated, so x cannot equal 0 is the domain of this function. In number 13, remember that an exponent 1/2 indicates a square root, so this is equivalent to writing k of x is equal to the square root of x plus 1 plus 3. And in a square root, the square root is only a real number if the expression underneath the square root is greater than or equal to 0, but not negative. So subtracting 1, x must be greater than or equal to -1. In number 14, there is no division, no even root, no logarithm, no problem. The domain is all real numbers. In number 15, I do not see a division, I do not see an even root, but I do see a logarithm. The argument of this logarithm must be a positive number, so must be greater than 0. So the domain of this function is x is greater than 0. In number 16, I don't see any division, I don't see any even roots, I don't see any logarithms. So there is no problem, and the domain is all real numbers. In 17 through 24, we're finding the range, and suggestion is to find the range by using transformations. The parent function here is y is equal to the square root of x, which is going to look like that. And the transformation is a vertical flip and movement up 7. So if we vertically flip this graph and move it up 7, then the graph will look like this. So the range is y is less than or equal to 7, because the highest y value is 7 and all other y values are below that. In number 18, the parent function is y equals x cubed, and transformations of this function are that it is moved right 5 and up 1. So the transformed graph of this function will look like this. Arrows on both ends mean the y values continue both up and down infinitely with no breaks, so the range on this is all real numbers. In number 19, the parent function is y is equal to the log base 2 of x, and the graph is transformed by moving it left 1 and down 2. So if we move it left 1, the vertical asymptote will happen at x equals -1. And if we move the graph down 2, it will look something like this. Arrows on both ends of the graph with no breaks in between indicate that the range of this function is all real numbers. In number 20, our parent function is y equals x squared, and the transformed function is a shift left 3 and down 5, which will give a graph that looks like that. The range of this function can be found by considering the lowest y value, which is -5. All other values are greater than that or above it, so y is greater than or equal to -5. In 21, we have an absolute value function, so our parent function is y equals the absolute value of x, which is that V shape. And this graph that is transformed is moved right 1, up 3, and is vertically stretched and also inverted, because there's a vertical reflection on this graph. So the transformed graph will look like this. The range of this function can be found by looking at the top y value. Since the graph doesn't continue infinitely above that, so the top y value is 3. All other y values are below it, so the range of this transformed function is y is less than or equal to 3. For number 22, we can also consider our parent function here. Our parent function is y equals x, and the transformed function is a vertical compression by a factor of 2/3 and a movement up 4. So the transformed graph will look like this, roughly. And the range of this is all real numbers, since the graph continues infinitely down and up in both directions with no breaks. In 23, our parent function is y equals 2 to the x, which has a graph that looks like this. And the transformations are a reflection over the y-axis, or a horizontal reflection, followed by a translation up 3. So if we translate the graph up 3 and reflect it horizontally, the transformed graph will look something like this. So notice that all the y values fall above the line where y is equal to 3, so y is greater than 3 is the range of this function. For number 24, we start with that same parent function from number 23, which is y equals 2 to the x. However, this time, the transformations are a vertical reflection, since 2 to the x is being multiplied by -1 on the outside, and then a movement up 3. So the graph will move up 3, but since it's vertically reflected, the transformed graph will look like this, resulting in y less than 3 for the range. In number 25, the parent function is y equals x squared. And the transformed function is a vertical reflection and moved up 2. So the transformed function will look something like this. The highest y value in this function is 2, so all other values are below it, so y is less than or equal to 2 is the range of the transformed function. In number 26, we have a square root function, so the parent function looks like this, roughly, and the transformed function is simply moved left 1 and down 4. And so the range of this function can be found by considering the lowest y value, which is -4. All other y values are above, so y is greater than or equal to -4. For 27, the domain of a function f of x is x is greater than or equal to 1. So I'm going to draw this on a horizontal number line. X is greater than or equal to 1. And then for the function g of x, which is a transformation of f of x, the horizontal transformation is a movement left 2. So if we move left 2 from 1, that gives us -1 on the number line. And if I translate that shading left 2, then x must be greater than or equal to -1. We can do the same for the range. So for these, I'm going to draw a vertical number line, one for f of x and one for g of x. And for f of x, the range is y can't equal 5. So that's an open circle on 5, shading everywhere else. And the range for g of x is found by translating down 3. So if we translate that down 3, we arrive at 2 is the location of the open circle, shading everywhere else. So the domain and range of the function g of x are x is greater than or equal to -1 and y is not equal to 2. In 28, we have the domain of a function p of x. That is, x is not equal to 2. X is not equal to -2. So that's open circle on -2, shading everywhere else. And the transformed function h of x is a translation right 5 from there. So if we go right 5 from -2, that arrives at +3. And so the open circle will be on +3 rather than on -2. Let's do the same for range. I'll draw a vertical number line for each, one for p of x and one for the transformed function h of x. The range for p of x is y is less than 5. So y is less than 5 looks like this. And the transformation that's happening is a vertical reflection. So a vertical reflection will move that 5 to -5 on the number line. And the shading will now be upward. And so the domain and range of the transformed function h of x are x is not equal to 3 is the domain, and y is greater than -5 is the range.